All right, in this video, we'll be working on a very complicated integral problem. You can see you have 81 x to the 18 over square root of 81 minus x squared dx. So this problem can be solved using a simple trig substitution. So when I see 81 minus x squared, so look like if I take x equals sine theta, that will be helpful. So how do you do that? First say that x equals sine theta. And since I have 81 here, so that will not give me 1 minus sine squared like this one here. So what I do, put another constant here, 9. So then x squared will give me 9 squared sine squared theta. So 9 squared is 81. So when you pull 81, you get 1 minus sine squared theta. That will be simply cosine squared theta. So there is the motivation that you make trig substitution like this. And then let us find what we have under the radical sign. So first I will try 81 minus x squared is what? So you have 81 minus x squared will give you now 9 squared is 81 sine squared theta. And then you can factor out 81. You get 1 minus sine squared theta. And then when I take the square root on both sides, 81 minus x squared. So that gives me, when I put a square root on this side, this is 9. And then 1 minus sine squared theta is cosine squared theta. And outside the radical sign, it will come out as cosine theta. I hope you understand this substitution. And then let us plug all this back here. Also determine what is dx. So dx, if you take the derivative, that will give you 9 cosine theta d theta. That's your dx. So we are ready to make all these substitutions. So square root of 81 minus x squared gives me 9 cosine theta. And I want to keep more complicated. Let me put here exponent 21. All right. So this will be more complicated. That's fine. So then we write here now 9 cosine theta. And our exponent is 21. And then 81 is here. And you have x equals 9 sine theta. Exponent is 18. And then dx we have found 9 cosine theta d theta. Now let's see what happens with the simplification. So first of all the constants we want to pull outside. So you have 81, pull it here. Then you have 9 to the 18. Then you have another 9 over there. And then you have cosine theta over, and I want to keep integral sign also, 9 to the 21, and then cosine theta to the 21 d theta, right? And then we see further simplification what happens. Sorry, I forgot one term here, which is x was 9 sine theta, so I forgot here sine theta to the 18. So sine theta to the 18 exponent in here. So let us do more simplification. So 9 to the 18 and 9 to the 1 is 9 to the 19. So I'm getting 81 times 9 to the 19 over 9 to the 21. And then I have cosine theta will cancel one cosine theta in the denominator. So in the numerator, I get sine theta to the 18 and then cosine theta to the 20. One cosine theta is cancelled like this. All right. So next what happens? We are almost there with very basic substitutions. Now this one you can see 9 to the 19 and 9 to the 21 will give you 9 to the 2. So basically if you just simplify that, will give you just 1. You can verify. And here I will do some trick like sine theta has 18 and cosine theta has 20. So let us split like this. sine theta over cosine theta to the 18. So still I have cosine squared theta remaining. Is that true? Because cosine theta 18 exponent and cosine 2 altogether 20. So what happens actually in this? Sine over cosine is tangent. So you get tangent theta to the 18 times 1 over cosine is secant. Secant squared theta d theta. Now this integral is very comfortable because we have some pre-knowledge, like if you take tan theta as u, then secant squared theta will come out by the substitution method. So I'll show you that. So I just clean up the screen so that we can see everything clearly. We call again u substitution equals tan theta. So then my integral looks like now u to the 18, and then secant squared theta d theta is du. So then the integral of this one is u to the 19 over 19. And what is u? Is tan theta. So you are getting 1 over 19 tan theta to the 19. Now we need to go back from tan theta to x conversion. So for this one, remember x equals 9 sine theta. So then easily you can say sine theta is x over 9. And we can easily produce a right triangle. This angle is theta. And sine theta we know opposite over hypotenuse. And by the Pythagorean theorem, this one is like 9 squared minus x squared, which is 81 minus x squared. All right. So then what is my tan theta here? X over this, right? So we know tan theta is opposite over adjacent. So x over the square root of 81 minus x squared. So that exactly we are going to put it here. And we are done. So let me plug the values and simplify the answer. 1 over 19. And now tan theta we have got x over the square root of 81 minus x squared, and the exponent is 19 plus integral constant, and we are done.